there's going to be techniques or methods to evaluate limits. One, always try direct substitution first. If you can put in direct substitution, do that first. But if it doesn't work and it gives you 0 over 0 or something that you're not aware of, something you can't deal with, you might have to do some of the following. You might have to factor cancel. Would you like a quick example of factor cancel? Here's an example of factor cancel. X squared minus 4 over x minus 2. The limit as x approaches 2. If you put 2 in, does that give you 0 over 0? Okay, 4 minus 4 is 0, 2 minus 2 is 0. So yes, that gives me 0 over 0. Can you factor the top? X plus 2 times x minus 2. Cancel with the bottom, what am I left with? And if I let the x change to a 2, what do I have? I have an answer of 4. So that's an example of factor cancel. Questions on that? We'll do a lot of factor cancel, I'm sure. Rationalize. You guys are so used to rationalizing the denominator, you may have to learn to rationalize the numerator. Many times that involves conjugates. 4 would be multiplying by the least common denominator. Five, when we're ready, we can't do it for quite a while, but you'll have something that makes it extremely easy called L'Hopital's rule. But to do L'Hopital's rule, you have to know derivatives. And I can't really do that, unless you know the derivatives. So these are the different techniques we're going to talk about. If you don't mind, I'm going to do an example of each. Is that okay? Anybody need this for a moment or two, or? So let's do a direct substitute. Let's go through one of each. Limit 3x squared plus 2 over x plus 3 as x approaches 1. Can you put 1 directly into that? Does 1 cause division by 0? If x is approaching 1 and I put 1's in, I think I get 5 over 4. Any questions on that limit? That's what I would say is direct substitution. Anything on that type? I'm sorry? Well, it doesn't have to be a fraction, but yeah, whatever you end up with. Let's do the limit as x approaches. How about if I did x squared minus x minus 12 over x minus 4 and have x approach 4? If you put in 4, do you get 0 over 0? 16 minus 4 minus 12 is 0 over 4 minus 4. I think it gives you 0 over 0. Would you agree? When you have 0 over 0, that's what makes it calculus, kind of. We have to deal with it. How does the numerator factor? I'll give you a hint. Many times it factors involving the denominator. So if there's an x minus 4 on the bottom, there's probably an x minus 4 on top. So that's x minus 4 times what? Those would cancel, leaving me x plus 3. We're doing the limit as x approaches what? 4. So I'm going to replace the x with a 4 and get an answer of 7. Now that's probably what I'd call factor cancel. Again, we did a direct substitution and we did a factor cancel. Now, how can you tell factor cancel? They have to factor, right? How can you tell if you have to rationalize? Well, if you have to rationalize, it probably has a radical. So I'm just going to make something up if it's okay. How about x plus 1 minus 2 over x minus 3? If you put a 3 into here, what do you get? If you put in a 3, do you get 0 over 0? If you get 0 over 0, you have to deal with it somehow. Now, let's see. Alonzo, you need paper? You getting this okay? Okay, your thumbs are moving fast on that phone as long as you're okay with that. Now, I'm going to ask somebody right now, somebody who's probably pretty good in algebra, what's a plus b times a minus b? Way back to algebra 1. Does anybody know? A squared minus b squared. It's called the difference of squares. These two over here are called conjugates. We're going to use conjugates to solve these. Now you're going to fight this a little bit, try to pay attention, see if this makes sense. What do I have in the numerator? I have a minus b. What's the conjugate of a minus b? A plus b. Again, please watch this to the best of your ability. So, I need to multiply this by the conjugate, which is a radical x plus 1 plus 2. The only thing that changes is a middle sign. X plus 1 plus 2. Now, did you tell me what a minus b times a plus b equals? Was it a squared minus b squared? Is that what it equaled? You really got to know your difference of squares. You ready? Okay, let's see. If this is a, what's a squared? x plus 1. Whenever you subtract, use parentheses, even though you don't need it here. If this is b, what's b squared? 2 squared is 4. Can anybody clean the top up? What would that give me on the numerator? Would it give me x minus 3? Yes? On bottom, what do you have, miraculously? You have an x minus 3. Could these x minus 3's cancel now? And what am I left with? Remember, we're doing the limit as x approaches what here? It's 3. So if I put a 3 in for that x, what do I end up with? 1 over the square root of 4 plus 2, 1 over 2 plus 2, or I believe this limit should equal 1/4. Now that technique's called rationalizing. I'm giving you it all at once. We'll go down and break it down into pieces eventually, but I want you to see all four main types together. Direct substitution, factor cancel, rationalize, and then finally least common denominator. Last type we're going to talk about is called the multiplying by the least common denominator. So let's create one. Let's do the limit as x approaches. How about 1 over x plus 2 minus 1/5 all over x minus 3. If I put a 3 in, would I have 1/5 minus 1/5 on top? One more time. If I put in a 3, would I have 0 over 0? You're aware, guys, that means I can't use direct substitution, right? If I put 0 in, it causes division by 0. It makes it impossible to do here. So we have to find a method. Do you know a common denominator you can always get by multiplying denominators? What are my two denominators here and here? Now, if I multiply by the common denominator, you can always get the common denominator by multiplying the two denominators. So 5 times x plus 2. When you multiply by the first one, the x plus 2's cancel, leaves you the 5. Multiply the second one, the 5's cancel, leaves you x plus 2. Always use parentheses when you subtract. When you distribute this negative, you get 5 minus x minus 2, or 3 minus x. 3 minus x is almost the same as x minus 3, so you factor a negative 1 out. Turning 3 minus x into x minus 3, that allows them to cancel. Then I can plug a 3 in, I get negative 1 over 5 times 5, or negative 1 over 25. Questions on any of this? New screen. We're going to do 11, 2, and I think we'll just do 1 to 43 odds. That's what, 24 questions? No, 23. So we're going to look at these. Some of these start pretty basic. Number 1 says a limit of 8 as x approaches 2. Is there any x to replace in problem 1? No. So what's your answer? Anything on 1? 2 is the limit of x as x approaches 2. Can I replace the x with a 2? Anything on 2? Three. Limit of 3x minus 4 as x approaches 6. So that means I'm going to replace every x with a...
Mr. Schultz, x approaches 2.
On problem 3? Oh, I'm sorry. I got these backwards. I numbered them wrong. What is, let's fix these up. Limit, this is problem 3, correct? I believe now, I hope I'm looking at problem 5. Does that look better? Now, what do you replace the x with? 6. Do you multiply or subtract first? You multiply. 18 minus 4 hopefully gives me an answer of 14. Would you agree these are mainly direct substitutions? I always say to try that first, because if you can do direct substitution, you're better off doing that. It's not always possible, as we see. Sometimes you get division by 0. Here, I think you'd square it and then multiply. Any questions up to and including 7? About 9. 9 is the limit as x approaches 5 of, I believe, x squared minus 3x minus 4. So I'm replacing every x with a 5. And what does that give me? 25 minus 15 minus 4, 10 minus 4. I hope the answer to number 9 is 6. I think up to at least 17 is direct substitution. When you get to 17 even, you have the limit of x over x plus 1 as x approaches what? 17, x is approaching 5. So I replace the x's with 5's. And I think that gives me my answer because, again, I can do direct substitution. Again, when you get to 19...
No, you can. You can do direct.
Can you?
Yeah.
19, I don't think so. If you put in a 1, oh, I'm
2.
sorry, 2 you can, you're right. Limit, you can, this one you can put a 2 in, because if you put in a 2 on top, I think you get a 3, right? If you put a 2 in on bottom, you get a 1. So you're right. 19, you can do direct substitution. 21, on the other hand, is the limit as x approaches 1 of x squared minus 1 over x minus 1. If you put 1 in, do you get 0 over 0? So does the top factor. Would it cancel with anything on the bottom? Now we're letting x approach what value? 1. So I get 1 plus 1, or 2 for number 21. I think that would be a factor cancel type.